This is the practice paper from First Class Maths. He has predicted this paper. I'm going to do the tutorial video that goes with it. I hope you find it helpful and hopefully this will help you prepare for Monday's Paper 3 exam 2024. Right, question number 1. Write down the value of the digit 8 in the number 18,235. So that 8 is worth 8,000. It's in the thousands column, so 8,000 would be our answer there. For question number 2, write down an integer, that's a whole number, that is less than -5. So less than -5 just needs to be more into the negative. I'm going to go -6, -7, -8, all of those numbers, as long as you were more into the negative than -5, that is smaller than -5. Question number 3a, a take away 7 equals 8. Now when we solve an equation, we just want to know what a is. And in order to get what a is, I need to get rid of that -7. The opposite of taking away 7 is to add 7. So we're doing the inverse operation, and on this side we would get 15. If I've got a number, I've taken away 7 to get 8. To get back to that original number, I'm going to add 7, and that is 15. Question number 3b, solve 5t equals 55. So if 5 lots of t is 55, and again we just want to solve it, so I just want to know what 1t is. I've divided this side by 5, so I also want to divide this side by 5, and that would be 11. Question number 4, here is a list of numbers, 1, 7, 9, 20, 36. From the list, write down a multiple of 10. A multiple of 10 is a number in the 10 times table, so we're going to say 20 as our answer there. Remember, 1 and 10 and 2 and 5, they are factors of 10. They're not multiples of 10. Multiples, you're looking for a number in its times table. So for 4 part B, from the list, write down a factor of 10. This time, we want numbers that fit into 10 an exact number of times. Our factors of 10 are 1, 2, 5 and 10. So the only number from the list that we can use is 1. For part C, from the list, write down a prime number. Our prime numbers are 2, 3, 5, 7, 11 and so on. So from the list we're looking for a prime number, and it's not going to be 1, it's going to be 7 there. 1 is not a prime number. It's a really common question that I get. A prime number has to have 2 factors, 1 and itself, and 1 only has 1 factor. So that's not a prime. 7 is your prime number there. Question number 5, simplify fully 12 to 30, that ratio. So to simplify a ratio, a bit like simplifying a fraction, we're looking for a common factor. So if you can't spot a bigger one, there's nothing wrong with dividing by a smaller number. So let's just divide by 2. They're both even, so let's do that. 6 to 15, and then you might spot that they're both in the 3 times table. So we're going to divide by 3, and that is 2 to 5. There we go. So that would be your answer. You could have spotted straight away that they're both in the 6 times table and divided by 6, which would have got you straight to your answer of 2 to 5, but there's nothing wrong with doing it in 2 steps. If you're not so good with your bigger times tables, that's absolutely fine. Question number 6, the bar chart shows the number of home and away goals scored by a football team 2020, 2021 and 2022. The number of goals scored, we've got up the y-axis there, and across the bottom we've got the years. So shaded in grey, that's the home goals, and in white, that's the away goals. Work out the year in which the team scored the greatest total goals. So we're going to add together the bars. For 2020, I've got 18 and 18, so 36 goals scored altogether. For 2021, I've got 22 goals there and 12 goals there. Adding them together, that's 34 goals scored in total. For 2022, this is 19 and this is 16. Adding them together, I get 35 goals. So the year where the most goals were scored is going to be 2020. For part B, work out the fraction of the goals scored in 2022 that were from home games. So 2022, we can see that 19 were home and 16 were away. So 19 were home and 16 were away. What is the fraction that were from home games? So that's 19 out of the 35 goals that were scored in total that year. Part C, in 2023, the team scored 40 total goals. 3/5 of these goals were scored at home matches. Work out how many goals the team scored at away matches. A couple of ways you can do this. I think I'm just going to go for the straightforward 3/5 of 40. So to do 3/5 of a number, we're going to divide by the bottom and then multiply by the top. 40 divided by 5 is 8. Multiply that by 3. 8 times 3 is 24. So that is how many were home. Now, if I want to know how many were away, I'm going to take that away from 40. So 40, take away 24 is going to be 16 matches that were away. Now, you could have just done 2/5 of 40, because if 3/5 were scored at home, then 2/5 were scored away. So that would have been another way to get the answer there. But however you did it, the answer needed to be 16. Question number 7. Write a number in each of the boxes below to make the statements correct. A add B. Now we know that with A and B, if I added them together, that is going to be the angles on a straight line. So my answer here is going to be 180. A take away C. Now A and C are opposite angles. When you've got two lines like this, the angle here and the angle here would be equal. So we don't know what they are, but whatever they are, if we start with A and we take away C, we're going to get nothing. So they are the same, so the difference would be 0. A plus B plus C plus D, so that's all of the angles around a point, and that adds up to 360. Question number 8, here is a triangular prism. Complete the table below. So we've got a triangular prism and we want to have the number of faces, which are the flat surfaces. So I've got a triangle on the front, a triangle on the back, I've got a rectangle on the floor, a rectangle on that side, and a rectangle on this side. So that is 5 faces all together. Faces is 5. Number of edges, we've got 3 on the front, 3 on the back, and 3 connecting, so that's 9. And then the number of vertices, they are like the corners. I always think the V for vertice looks a bit like a point. So 1, 2, 3, 4, 5, 6 vertices. Complete the bank statement, question number 9. So we've got the date going down the left, starting balance, council tax, birthday gift, salary. So credit is money coming in, debit is money going out. So if the starting balance is £3,252.23 here, and then council tax, we've paid it out. So I'm going to take this away from the balance because that is money leaving my account. £3,252.23 minus 219.99 leaves me with £3,032.24 in my bank account. I've then got a birthday gift of £30. So that's money coming in. So I'm going to add that back on, £3,062.24. And then my money has gone up by quite a lot here. I've got my salary coming in. It's in the credit column, so it's coming in. So to work out how much my salary is, it's going to be the difference between those numbers. So £5,642.28 minus £3,062.24. And the difference between those is £2,580.04. Very nice salary. We'll take it. Right, question number 10. Here is a number machine. The input is M, and it's going to divide by 4 to get the output. Write an expression for the output. So I need to do M divided by 4. An expression is stuff in terms of algebra and with the letters in them. So the output you could write as M divided by 4, like that. Or you could put a quarter of M. Either of those would be absolutely fine. I'm going to go for M divided by 4. Try not to use this. This is not as good a way of writing it, even though it means the same thing. 10b, here is another number machine. P is going to get multiplied by 2, then add Q, and we're going to get our output. So if I start with P and I multiply it by 2, I'm going to get 2p. And then I'm going to add Q to it, but because they're not like terms, I can't make that a single term, it has to stay like that. So the answer there is 2p, add Q. Question number 11. The table shows the number of exams sat in a week by 20 students. Write down the modal number of exams sat. So the frequency is how many students sit that exam. So I've got one student sitting no exams. I've got 2 students sitting 1 exam. I've got 3 students sitting 2 exams. 12 students sitting 3 exams. So that seems to be the most common number of exams, the mode being the most common. So 3 would be my answer because 12 students are sitting 3 exams, whereas there are less students sitting the other numbers of exams. Work out the mean. So to do the mean, we're going to say 1 student sat no exams, which is no exams. 2 students sat 1 exam, which is 2 exams. 3 students sat 2 exams, which is 6. We're just multiplying across here. 12 students sat 3 exams, which is 36 exams. And 2 students sat 4 exams, which is 8. We're then going to add all of that together. 36 add 8 add 6 add 2. And that is 52 exams in total between the 20 students. So we're going to do the total number of exams divided by how many students there were. 52 divided by 20 is going to be 2.6. So on average, they sat 2.6 exams each. Question number 12. Here is a circle with centre O. O to A is 9 centimetres. Work out the circumference of the circle, give your answer to 1 decimal place. So circumference is given by pi times diameter. You also might know it as 2 pi r. So whichever way you do, absolutely fine. We need the diameter or we need to double the radius, and that's going to be the same thing. So all the way across is going to be 9 and another 9. So the diameter is 18. So I'm going to do pi times 18 and then give that answer as a decimal. So 18 times pi. It's going to come up 18 pi first. You're going to want to press that SD button. 56.54866, blah, 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 blah. And that's going to be 56.5 to 1 decimal place. Here is a trapezium. Work out the area. So area of a trapezium is half A plus B multiplied by the height, where A and B are your 2 parallel sides. So I'm going to do half times 6 add 7.5. And we're going to multiply that by the height, which is 2.8. So let's just type that in my calculator. And I get 18.9 centimetres squared. Lovely. Question number 14. Simon drives 96 miles from Manchester to Birmingham. He leaves at 10 a.m. and drives at an average speed of 40 miles per hour. Will Simon arrive in Birmingham before 12:30 p.m? Tick 1 box. Show working to support your answer. So 96 miles and he's going 40 miles an hour. So let's do our speed, distance, time triangle. We would like to know the time. I want to know how long it's going to take him. So I'm going to do the distance, 96, divided by the speed, which is 40. 96 divided by 40 gives me a time of 2.4. Now, be careful here. This is 2 hours and 0.4 of an hour. So if I do 0.4 times 60, that's going to tell me how many minutes that is, which is 24 minutes, because I want that proportion of 60 minutes. It's not 40 minutes because your calculator doesn't know you're working in time, that it's out of 60. So we just need to do 0.4 times 60 to find out how many minutes that is. So he's going to get there 2 hours and 24 minutes after he left. So if he left at 10 a.m, 2 hours and 24 minutes after that is going to be 12:24 p.m. It's in the afternoon at that point, isn't it? So there we go. Does he get there before 12:30? Yes, he does. 12:24 is before 12:30. Question number 15. Expand h add 2. So h times h is h squared. When we times a letter by itself, we're squaring it. And then h multiplied by 2 is 2h. Can't bring them together because they're not like terms. So that is your final answer. For 15b, we have to factorise. So factorise means putting into a bracket. I'm looking for the biggest number that they've got in common, or the biggest thing they've got in common. They don't both have a, there's no letters in common here, but they are both in the 20 times table. So I'm going to put 20 on the outside, and then that would be a add 4, because 20 times a is 20a, and 20 times 4 gives me the 80. You might have thought 10 is what comes on the outside because both 20 and 80 are in the 10 times table, but we're always looking for the biggest number that we can. In this case, 20 was the highest common factor of 28 and 80. Question number 16. The table shows how many sales a business makes for 4 different years. Number of sales, we've got 3,000, we've got 2019 that's missing, 3,200 for 2020 and 2,560 for 2021. Between 2018 and 2019, the number of sales increased by 12%. Work out the number of sales for 2019. So we want to increase 3,000 by 12%. So that means we want 112% because we want the 100% of 3,000 that we started with and an extra 12%. Now to get that, we multiply by the decimal equivalent. So 112%, if we divide by 100, is 1.12. So if I multiply by 1.12, that is going to get me my answer straight away. Now you could do 3,000 and you could divide it by 100 to get 1%, times it by 12 and add it on. Nothing wrong with that. Just this is going to be much quicker to get straight to our answer, and it gets me 3,360. I'm going to put that up there and on the answer line. Then for 16b, it says between 2020 and 2021, the number of sales decreased by X%. Work out the value of X. So we're going here to here. Now percentage change is change over original times by 100. So it's gone from 3,200 to 2,560. So we're going to do change over original times by 100. Now the change is going to be the difference between them. So I'm going to do 3,200, take away 2,560, and that is 640. Out of the original, so what was it first? It was 3,200 times by 100. So 640 out of 3,200, the original, times by 100 is going to tell me that the decrease is 20%. 20% being our decrease there. Okay, question number 17. A coffee shop owner recorded the orders of 100 visitors. This funny squiggly E is our universal set. So that's everything we know about. That's all of the total data. F are the number of people who ordered food. D is the number of people who ordered drinks. Complete the frequency tree below. So we've got 48 people who got food and drink, and we've got one person who visited the coffee shop and didn't get any food or drink. So total number of visitors is 100. Did they order food or did they not order food? Okay, so how many people ordered food? That's going to be all of the people in that circle. So 27 add 48, because 27 just got food, 48 got food and drink. So there are 75 people. If I put 27 add 48, 75 people who got food. And therefore there are 25 people who did not get food. They are here and here. Great. Now, of the people that ordered food, of the 75 people that ordered food, how many of them ordered a drink? Well, that's just those people there. So 48 of them ordered a drink and 27 didn't. And those two add together to make 75. So we're happy with that. And then down here, of the people that didn't order food, so that's 25 of them. How many of them got a drink? Well, there are 24 people who got a drink and one person who didn't get any food and didn't get any drink. So that would be those two adding to make 25 there to make that one complete. Question number 18. Here is a regular pentagon. So regular means that all of the sides are the same length, which means that all of the angles on the inside are the same size as well. Write down the letter of the angle that is an interior angle. So that would be Y. Y is our interior angle. It's one of the angles inside the shape. Write down the letter of the angle that is an exterior angle. That's going to be Z. When you have an exterior angle, it's not the entire bit outside. It's just the angle that is made if you were to carry on one of the lines. So Z. Work out the size of the angle marked Z. So the exterior angle is found by doing 360 divided by the number of sides. So in this case, that's 360 divided by 5, which is 72 degrees. Question number 19. Shape A and shape B are shown on the grid below. Rotate shape A 90 degrees anti-clockwise about -1 1. Minus 1, 1 is here. If I'm going to go 90 degrees anti-clockwise, then we're going in the opposite direction to a clock. So we're going to go this way here. Now, this is when you'd put your tracing paper over the top. You would draw round A and you would spin it 90 degrees until it is facing that way. What would happen? This point here, at the minute, it's 3 down and 2 left. It would end up here. So that's going to help me slightly. When I spin it, it's going to look like this. And B here. That's C. And then for part B, reflect shape B in the line y equals 3. So y equals 3 goes through the y-axis at 3. So the line y equals 3 looks like this. Goes through 3 on y. And so we're going to reflect, let me get rid of this. We're going to reflect the shape in that mirror line. So let's do that here. The same distance away on both sides, so it would look like that. That's the line y equals 3, goes through 3 on the y-axis, and however many squares away from the mirror line you are on this side, it's going to be the same on that side. So what shape, what letter do we have to call that one? Let's have a look. That's going to be D, of course. There we go. Question number 20. Tom checks how many of his channel viewers are subscribers. He finds that the number of subscribers to the number of non-subscribers is in the ratio 2 to 13. Draw and label a pie chart to show the subscription status of Tom's viewers. Okay, so we know that this needs to be 360 degrees altogether. So I've got number of subscribers, 1, 2, to number of non-subscribers, 6, 7, 8, 9, 10, 11, 12, 13. Altogether then, there are 15 parts. So I'm going to take the 360 degrees of my pie chart and divide it by 15. 360 divided by 15 is 24. So each of these little lines has 24 on them. I always say I'm not going to do them all, and then I do them all because it feels wrong to not complete it. So therefore, on the left-hand side, you've got 2 lots of 24, so 48 degrees there. And on the right-hand side, I've got 13 lots of 24, which is 312 degrees. We've now just got to draw that on the pie chart. So my protractor doesn't work on my iPad, so you're going to have to humour me here. So you're going to put your protractor this way so that the 0 is facing up. You're then going to read round until you get to 48 degrees. It's going to be around here. Let's just say it's about here because I don't have an actual protractor to put on the screen other than you won't be able to see it because I'm screen recording. Anyway, so then you're going to make a mark like that, join it up to the line, better than I did, and then you're going to label that bit is subscribers and that bit is not subscribers. If you had more than one section that you were drawing, you'd then put your protractor like this with the 0 starting where your last section just finished, but we only had 2 sections to draw there, and it should look a little bit like that. You might have gone the other way. You might have had your section there and the other section the other way, but there we go. A small section of 48 degrees for subscribers, and the rest would be not subscribers. Question number 21. The first 2 terms of a sequence are shown below. We've got 10, 15, something, something. Devon assumes it is a linear sequence. Work out the next term of the sequence using Devon's assumption. So linear would mean it would be going up by the same amount each time, adding on the same amount. If you plotted it on a graph, it would make a straight line. So he's assuming if it's add 5 there, that it's going to be add 5 again and add 5 again. So adding 5 each time, the next 2 terms, or work out the next term, is just going to be 20. So adding 5, let's do some working, 15 add 5 is 20. For part B, Sarah assumes it's a geometric sequence. A geometric sequence is when we're multiplying each time. So to get the multiplier, we would do 15 divided by 10. 15 divided by 10 is 1.5. So that means it's multiplying each time by 1.5. So 10 to 15, that's multiplied by 1.5. And to get to the next term, we're going to multiply it by another 1.5. 15 times 1.5 gets us 22.5. So if it was geometric, that would be the next term. For part C, Morgan assumes it's Fibonacci type sequence. Work out the next term of the sequence using Morgan's assumption. So Fibonacci is when you add the 2 terms to get the next one. So 10 add 15 would give us 25. And then if we were going to carry on again, we'd do 15, add 25, and we'd get 40. But we only have to do the next one, so 25 would be our answer there. Chuck assumes the sequence is the triangular numbers starting from 10. Work out the next term of the sequence using Chuck's assumption. So triangular numbers, think about the format of the pins when you go bowling. So the first triangular number is 1, then we have 3, then we have 6, then we have 10 pin bowling, then we have 15, 1, 2, 3, 4, 5, and the next one would be got by adding a row of 6 along the bottom. So we just had 15, we would then add 6 more underneath, so 21 would be the next number if we were using Chuck's assumption. Here is a cuboid made from metal. The mass of the cuboid is 1 kilogram. Work out the density of the cuboid in grams per centimetres cubed. So we've got centimetres, centimetres, centimetres here. I've got grams per centimetres cubed as my density. So I'm going to need that density formula triangle. Density, mass, volume. And if the density is in grams per centimetres cubed and the volume, once we work it out, is going to be in centimetres cubed, then we're going to want to make sure that the mass is in grams. So 1 kilogram is 1,000 grams, so that's what we're going to use. The volume of a cuboid is found by doing the area of the cross-section multiplied by how far back it goes. In this case, we could just do 4 times 3.2 times 9.5 in any order. That's going to be fine. So I'm going to type that in my calculator. 4 times 3.2 times 9.5. And that's going to give you a volume of 121.6 centimetres cubed. Now work out the density. So if we want the density, cover that up and do the sum that's left behind. So we're going to do mass divided by volume, which is 1,000 divided by 121.6. 1,000 divided by 121.6 gives me a density of 8.22368 and so on. We're going to give that to, let's just go for 3 significant figures, 8.22. Question number 11. Here is a triangle with an area of 330 centimetres squared. Work out the perimeter of the triangle. So we know that the area of a triangle is base times height divided by 2. So 60 multiplied by x, because we don't know the height at this moment in time, divided by 2 equals 330. Let's solve this equation then. We're going to do that by multiplying both sides by 2. That gets rid of the fraction. So 60x equals 660. And then we're going to divide by 60. So x equals 11. So x equals 11, and that tells us then that that is the height. So I can pop that there. I then want to know the perimeter of the triangle, and the perimeter is the distance all the way around the outside. So 60 add 11 add something, let's call it y. Now to get y, we're going to use Pythagoras. So 11 squared add 60 squared, and then we're going to square root that answer to find out what y is. 11 squared add 60 squared is 3,721. Let's then square root that answer, and that gives us 61. So 61 is the hypotenuse. Now let's add all of that together to get the perimeter. 11 add 60 add 61, and that gives us a final answer of 132 centimetres for 5 marks. Question number 24. ABCD is a quadrilateral. Work out the size of angle BCD. So this is 90 degrees here, right angle. And we know that all of the angles inside a 4-sided shape, a quadrilateral, add up to 360. So I'm going to write 90, add 10x, add 17, add 8x, add 12x minus 2 equals 360. So all of the angles inside that quadrilateral added together equal 360. I'm now just going to collect up my like terms. So I've got 12x, 8x and 10x. So that is 20x. And then I've got 90, 17, take away 2. I should have done that in a different colour, shouldn't I? 90 add 17 is 107. Take away 2 is 115. So 20x add 115 equals 360. Take away the 115, means that 20x is 245. And then divide that by 20. 245 divided by 20 is 12.25. So if x is 12.25 and we want the size of angle BCD, this one up here, then I need to do 8 lots of x. And 8 lots of x means 8 lots of 12.25, which is 98. 98 degrees. Does that look about right? Yeah. No, not even close. Doesn't look right at all, does it? But it is. So we'll move on. Question number 25. ADF is a straight line. Line AB is parallel to line DE. A to C is equal to B to C. So that's an isosceles triangle at the top there. Work out the size of the angle marked X. Give reasons for your answer. So what I'm going to look at here is if there are any alternate or corresponding angles. Now remember Z, that makes your alternate angles, and that F shape, that makes your corresponding angles. Corresponding and alternate is how I remember them. So I'm going to have a little look for that. And if I look here, I've got that corresponding angles, that F shape there. So this angle here, 108, and this angle all the way to that parallel line would be equal to 108, both of them, because corresponding angles are equal. So the first thing I'm going to do is write BAD, this angle here, angle BAD equals 108 degrees because corresponding angles are equal. And if I know that that is 108 all the way, then this bit here must be 28 degrees because I've done 108 take away 80. Now, that's an isosceles triangle at the top. So if that one's 28, then this one is also 28 because base angles in an isosceles triangle are equal. So let's put angle ABC because base angles in an isosceles triangle are equal. I apologise for my handwriting. And then we know that X will be whatever it needs to be to add to make 180. I'm looking at this triangle here, and angles in a triangle add up to 180. So I'm going to do 28, add 28, which is 56, and then 180, take away 56 is 124. So we know that X equals 124 because angles in a triangle add up to 180 degrees. So the answer we're looking for is 124. And last but not least, question 26, simplify x to the power of 4 to the power of 5. A power of a power, you're going to multiply those powers together. So that is x to the power of 20. If you had x to the power of 4 times x to the power of 5, that would be x to the power of 9. But that isn't what we've got here. We've got a power of a power, so we multiply them together. For part 26b, I'm going to do 4 divided by 8, which is going to be a half. And then y to the power of 10 divided by y to the power of minus 2. When we divide, we take away the powers. So I need to do 10 take away minus 2. And 10 minus minus 2 is actually going to add 2. So that's 12. So it's a half y to the power of 12. Or you could write that as y to the power of 12 over 2. I'm going to go for that because I think it looks a bit nicer. Y to the power of 12, all divided by 2. End of questions. There we are. I hope you enjoyed it. Please let me know in the comments if you've got any questions at all. I don't often do the AQA stuff, so it was nice to do a little bit of AQA for you all. Let me know if you've got any questions, and I will see you all soon.